NASA's next-generation moon rocket is being put through a series of crucial tests, a so-called wet dress rehearsal, to determine how soon it can fly. The SLS Orion cost nearly $37 billion to develop and is a key part of US plans to renew lunar exploration. Well, let's talk now to Professor James Head, who has trained astronaut crews in geology and surface exploration and helped select landing sites for the Apollo moon program. Welcome back to the program, Professor Head. So tell us, what will this wet dress rehearsal consist of, and what kind of information are scientists trying to find out from it?
Well, it's very important. It's like if you were in a play, in a theater. Basically, everybody has to learn their part. They have to go practice their part. And then you have a rehearsal and you say, oh, no, you go back and work on yours. And then just before all the tickets are sold and everybody shows up, there's a dress rehearsal. And that's exactly what's going on here. Everybody has to know their part. It all has to come together, including the steps of fueling the rocket, stop fueling the rocket, unload the fuel, do the countdown, stop the countdown, do all the things that are likely to happen in the first launch, which we hope will be a little later on this summer.
So when it does blast off for real, what's the goal behind the mission?
Well, in this particular mission, it will be to demonstrate the capability of obviously lifting off the ground, getting into Earth orbit, heading to the moon. And when it gets to the moon, it'll go into an orbit around the moon. This does not have any astronauts on board, Artemis 1, and it will then be able to come back out of orbit, come back and splash down onto the surface of the Earth and the oceans. And a key part here is that it takes the Orion spacecraft. It's about the Space Launch System, but also the Orion spacecraft. The data from all the flight recorders, like you think about in airplanes, are on the Orion spacecraft. That will be recovered, all the analysis will be made. Then we'll set the stage for next year, Artemis 2, which will carry 4 astronauts in a loop around the moon, like Apollo 8 was many years ago, and then Artemis 3 to land humans on the moon again.
So this is then a precursor of an eventual manned mission to the moon, as you say. What's left to find out about the moon?
Well, the moon is really the Rosetta Stone for understanding Earth. The Earth is so active, it's, plate tectonics, erosion, et cetera, that we don't have very much of a record for the first 2/3 to 3/4 of the history of our own planet. And if we want to know where we're going in the future, like with global warming we just heard about, then we need to know where we've been in the past to see that trajectory. The moon reveals it all. It reveals the earliest history of our own home planet Earth, and that's critically important for understanding how we basically operate in the future. And so the astronauts will go there and they will be able to, in fact, bring back rocks, make observations about these processes, and we hope that it's not manned operations, it's human operations, and this will be landing Artemis 3, the first woman and the first person of color on the moon. And we hope that one of those will be one of my students, Jessica Meir, who is an active astronaut at the present time. That's my dream.
And you were, of course, involved with the Apollo missions to the moon, the last time that humankind landed there. How excited are you that this work is now, in a sense, being continued?
I think it's very important. It is very expensive. There's no question about that. But I think it provides not just fundamental scientific information about how we all came about, where we are in the cosmos, and where we're going in the future, but it also provides inspiration. I think, we have so many problems here on the Earth, and we can say, why spend this money to go into space when we have so many problems? But just as with the Apollo program, it gave us inspiration. We looked back on the Earth and said, we have a lot of problems, but look, it's one planet. It's one planet. Can't we all work together? So I hope it'll be inspiration as well as the scientific knowledge that we gain from all this. That's my hope.
Okay, Professor James Head, great to talk to you as always. Thanks very much indeed for joining us on the program.
Thank you very much. Thank you.